Go. Okay, next. Let's look at this submarine. The submarine is hovering right there. Okay? What would you say about the density, the total density of the sub relative to the water? Is the submarine more dense than the water, less dense than the water, or the same as the water?
More dense.
No.
It's the same.
It's not sinking or floating. It's just staying right there.
It's just
So
moving.
when it's not,
Yeah, if it's staying right there, it's the same density as the water, wouldn't you say?
because I thought that section was like under the water. So
It's under the water, but it's just floating under the water. It's right there.
okay.
It's not on top of the water.
Yeah.
It's just, it's not moving.
Okay.
What you see is what it is.
Okay.
Clear?
Yes.
In other words, the buoyant force and the weight are the same of the sub. Right?
Yeah.
Yes? So, what would you say about the density of the sub relative to the water? You would say that the density of the sub, you would say that the densities are equal. The density of the sub is equal to the density of the water. Would you say that? Yes?
Yes.
Okay, good. Now, this one here. It's important to know the general differences between a gas and a liquid. They're obvious. Gas molecules are farther apart. Clear? Gas molecules have higher kinetic energy. Gases are less dense than water.
Yeah, true.
So there are obvious differences between gases and a liquid. For instance, air, oxygen and nitrogen solution. The molecules of oxygen and hydrogen are much farther apart than in water. They're moving, the molecules are moving very fast, aren't they? They're
Yeah.
colliding.
Yeah, that's true.
Yes? The air is less dense than the water. So it's important to be able to think about the differences, the general differences between a gas and a liquid. Here's an interesting one. I have an ice cube. This ice cube is floating in water. The ice cube melts. Notice that there's no change in the level of water.
Yeah, that's a good question. Why?
Yeah, I did that before, remember?
Yeah, why? Yeah, why?
There's no change in the level.
Yeah.
You get that? Yeah, here's one that's interesting. Let's say I have an ice cube that has an piece of iron filing, large piece of iron, in the ice cube. Yes? So that ice cube melts. Yes?
Yes.
There's the iron, but look at the water level. It's much less. Why? Because that iron is forcing that volume farther down, correct?
Yeah.
And you're displacing a lot of fluid, aren't you? Right?
Yeah.
But look at and so the volume of that iron is small, but when it's attached to the ice, you're including the ice in the volume. Now the volume of that iron is small, yet the water level goes down. You see that?
Yeah.
Curious, isn't it? Okay, what else? Here I have basic densities. Density of B versus density of A. That's the symbol for density, rho. Correct?
Yeah.
What has a higher density? A or B?
B.
B has a higher density. Here's one. A and B. What has a higher buoyant force? A or B?
B.
B has a higher buoyant force because it's displacing a greater volume
Yeah.
of fluid.
Yeah.
Clear?
Yeah, that's right.
Okay, next. don't forget Archimedes' principle. Archimedes' principle is that the buoyant force or the upward force is equal to the weight of the fluid displaced. The buoyant force, this is what Archimedes' principle says. The buoyant force exerted on an object immersed in water is equal to the weight of the water or fluid displaced. Easy?
Easy.
You sure?
Easy.
Okay. So, I have three scenarios. Okay? I have three scenarios. Okay? Scenario one. The buoyant force and the weight of the object are the same. Correct?
Yeah.
They're the same. Right?
Mm-hmm.
So, like the sub, they're the same.
Since it's not moving.
Correct?
Yeah.
Or if something is immersed in water and the weight is larger than the buoyant force, what's going to happen? This is going to sink. Correct? Or I have this. This means it's going to rise like a soccer ball. A soccer ball will rise because its buoyant force is greater than its weight, correct?
Yeah. Is it,
Yes.
is it basically like the way I say it, anything that has a particle that has like gas included in it, right?
Yeah, it's gonna, yes. Anything, yeah. Anything that has gas in it, any ball with gas, of course, it's gonna rise.
Okay.
And then if I have a piece of metal, a dense piece of metal, that's gonna sink, correct? And then, don't be confused about this. If I have a ship, that ship is floating, right? It's not rising, it's not falling. Therefore, it would be this. The buoyant force and the weight of the ship would be the same. Understood?
Yeah.
In other words, there's a net force here, means it's going to sink. There's a net force here, There's a net force here, means it's going to sink. There's a net force here, means it's going to rise. There's no net force here, zero. So this is an example of that.
Yeah.
Or if something is floating in the water, that's also an example of that.
Okay.
Clear?
Yeah.
Okay. Let's quit.